Hi everyone. Today we're going to review from grade 10 how to change a quadratic function from standard form to vertex form. So our learning goals are going to be reviewing how to change a quadratic from standard form, which is the form y equals ax squared plus bx plus c, to vertex form, which is the form y equals a x minus h all squared, so there's your quadratic, plus k. And why would you want to do that? Because in the standard format, it's not a very graphing friendly format. You would know the y-intercept would be c, and you would know the step number, but that's not enough to draw the graph accurately and easily. Whereas in vertex form, you know the vertex is hk, and you know the step number is a. Is a. So using the vertex and the step number, you can draw the graph easily. So we're going to review how to change forms, how to graph a quadratic function in vertex form, and how to find the maximum or minimum value of a quadratic function. So if you remember from grade 10 that the most graphing friendly format of a quadratic function or parabola is vertex form. And I've got it written again here. Vertex form is y equals a x minus h squared plus k. In this format, the vertex of the parabola is located at the point hk, and the step number is a. So first question we're going to do is to graph the parabola, already given to us in vertex form. Sorry. Okay, so this one's already in vertex form. So from this, we should be able to know that the vertex is at -4. It's the opposite of the number inside the parentheses. And you remember even when we did transformations that x plus 4 meant 4 to the left, so the vertex will be -4 for the x and +7 for the y value. So we could plot the vertex. 1, 2, 3, 4, 1. There's the vertex. And our step number, our a value, is -2. And if you remember, if your step number was 1, it would be up 1, up 3, up 5. But if your step number is -2, it means you're going to go over 1, down 2, like 1 times 2, over 1, down 3 times 2, which is 6, and over 1, down 5 times 2, which is 10. Okay? All right, so from here we're going to go over 1, down 2, both sides, over 1, down 6, and over 1, down 10, which doesn't quite fit on, but we've got a good sketch going here. So again, remembering from grade 10, even from chapter 1, this is the vertex here, okay? Vertex. Grade 10, also maybe you would have drawn in the axis of symmetry. So that means if you folded your parabola in half along this dotted line, called the axis of symmetry, the two lines would line up on top of each other. And you can also see that this particular parabola has a maximum value. So it never gets higher than +7. So we would say that this parabola has a maximum equal to 7. And notice that that 7 appears in the equation. And in the vertex. It's the k value in the equation, and it's the y coordinate of the vertex is the maximum value. And what lets me know it's a maximum is that the step number is negative, which means as soon as you see the negative step number, you know that your parabola is pointing downwards, so it will have a highest or a maximum value. Okay, so that's just, once you've got it in vertex form, how do you draw it? Okay, a little refresher from grade 10. So now we're also going to refresh from grade 10. how to change from vertex form to, or sorry, from standard form to vertex form. Okay, so draw a graph of this parabola by changing it into vertex form. So how do we do this? So I'm going to start just recopying our quadratic that's in standard form right now. So far, we would know that this parabola was opening upwards because the step numbers of 1 are a positive number. So we know it's going to have a minimum value, but we don't know its vertex. We do know its y-intercept is 3, so that's going to be a point on our graph 0, 3. But we would like to find the vertex, so we're going to put it into vertex form. So this procedure called completing the square is how you put it into vertex form. So what do we mean by completing the square here? So we're trying to go from this form into this form. So y equals a, which is a positive 1, so that won't affect us much. And then we need this x part of the vertex, and then our k value. And if we change it into that format, we'll have the vertex. So to get the what I call the x part of the vertex, we have to do this thing called completing the square. So to complete the square, you want to put a number in here that makes these 3 terms a perfect square trinomial, okay? Which means that when you factor it, the 2 numbers that multiply to give you this will also add to give you this, and they'll be the exact same number. So the way that you make sure that that happens is you take half of 6, which is 3, and then you square 3. So that means the number that completes the square is 9, okay? So we can't just, this is an equation. We've got y on one side, and we've got, in the beginning, x squared plus 6x plus 3 on the other. And we know the rule of equations is whatever you do to one side, you do to the other. But we do want to have y by itself because we are trying to get this vertex form over here. So instead of adding 9 to both sides, what I can do is add 9 on the right side, but then quickly subtract 9 as well. So really all I've done is add 0, which doesn't change anything, but I still need this plus 3 as well. But what's in the box here is a perfect square trinomial. So when you factor it, you can think of it as a simple trinomial, but it's really a perfect square trinomial. The 2 numbers that multiply to 9 and add to 6 are both positive 3. So this part here factors to give you x plus 3 times x plus 3, or x plus 3 all squared. And because we took half of 6 and squared it, we made sure that that would happen. So this gives me my x part of my vertex. And then if I take the minus 9 plus 3, that gives me minus 6. That forms the y coordinate of the vertex. So now I've changed it from standard form, where I just knew the y-intercept and I knew it opened upward, to vertex form, where I now know the vertex is negative 3, opposite, negative 6. And I know the step number, the number out front is a 1, which means I'm going to go over 1, up 1, over 1, up 3, over 1, up 5, and then 7 and 9 if it fits. So let me plot my vertex, negative 3, negative 6, and then apply my step number. So from the vertex here, I'm going to go over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. Oh, there's my y-intercept. 1, 2, 3, 4, 5. And then 7. 1, 2, 3, 4, 5, 6 just fits. And now you've got a nice sketch of your quadratic function. Okay, so draw a graph of this parabola by changing it into vertex form. We did that. Okay, next question. All right, rewrite each parabola in vertex form using the method of completing the square. Sketch the graph of the parabola and state its vertex and its maximum or minimum value. Okay, so first step, rewrite each parabola in vertex form using the method of completing the square. So we've got it in standard form. So we're going to do y equals x squared minus 10x. And then we're going to take half of 10. So you're thinking to yourself, so do a little thought bubble over here. Half of 10 is 5. And then we want to square that. 5 squared is 25. Okay, so that's the number that's going to fill our blank in and make a perfect square trinomial. So we're going to add 25, but so we keep a balanced equation, we're subtract 25 right away again, and then add 18. So this line, the first one we started with, and this are equivalent, because all we did was add 0. We added 25 and subtracted 25, so we could just combine like terms and we get back to what we started with. So I haven't done anything that changed the value. But then I've completed the square so that these first 3 terms in the box here form a perfect square trinomial. So when I factor it again, the way a perfect square trinomial works is square root of x squared goes in the front, sine from the middle term goes in the middle, square root of the last term goes at the end, squared. Okay? Or you can think what 2 numbers that are exactly the same multiply to positive 25 but add to negative 10, and they would both have to be negative 5. Negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. So you could also think of it as a simple trinomial that happens to have both factors identical. So then minus 25 plus 18 is plus 7. No, minus 7, sorry. All right, so we have done the first part. Rewrite each parabola in vertex form using the method of completing the square. Sketch the graph of the parabola and state its vertex and its maximum or minimum value. So we know its vertex is positive 5, negative 7. So we can plot that on our graph. And we know the step number, the number out front is a positive 1 again. So our step is over 1, up 1, over 1, up 3, over 1, up 5. Seven, 1, 2, 3, 4, 5, 6, 7 fifths again, so I can keep going. All right, so we stated its vertex, maximum or minimum value. So you can see that this one opens upward because it has a positive value of a. And so it's going to have a minimum. And the lowest down it ever gets is negative 7 again. So we can say the minimum is equal to negative 7. Okay. Next question. Okay, so same question, but this time different parabola. So we have y equals negative 2x squared plus 8x minus 3. So what makes this one more challenging is that a is negative 2. It's not positive 1, which was the case in the other two that we looked at. So remember, we're going for this format here where the a is out front. So the way you get the a out front is you factor the a value out of the terms that contain x. So in our case, the first 2 terms. So step 1, factor the negative 2 out of the terms containing x. So just get that step number a out front. So common factor again, negative 2x squared divided by negative 2. You mentally divide there, you get x squared Positive 8x divided by negative 2, though, is negative 4x. Okay? And then we still have minus 3. So again, we have equivalent expressions here. If I just distributed the negative 2 over that bracket, I would get back negative 2x squared plus 8x, and I'd still have the minus 3. I haven't completed the square yet. I'm going to complete the square inside the bracket here. So to complete the square again, I take half of 4, so my thought bubble, half of 4, that's going to be 2, and then we square 2 is also 4. So that means the number that completes the square is 4. But I can't just add 4, I have to subtract 4 as well, so I've really just added 0. Now I'm going to close the parentheses and then subtract the 3. So the issue that happens here is these first 3 terms inside the parentheses I can put in a box. That's what forms the x part of the vertex of the perfect square trinomial, but I'm still left with this negative 4 inside the bracket as well, which is going to have to come out because it's going to help me to get that k value I need up here. So I'm going to factor the x squared minus 4x plus 4. It's a perfect square trinomial, so it's x, sine from the middle term, square root of the third term, squared. But now I'm stuck with this negative 4 inside the bracket. To get a number outside of a bracket, you have to multiply it out. You have to expand it out. So like using the distributive property. So you have to take the number out front, the negative 2, and multiply by negative 4, and then it frees it or it gets it out of the bracket. So negative 2 times negative 4 is positive 8, but then I still have this minus 3. And then if I just collect those last 2, I've now successfully changed from standard form up here to vertex form down here. So the vertex of this one is going to be at positive 2, positive 5. So I could plot that. But this time my step number is negative 2. Which means I would go over 1 down 1 times 2, which is 2, over 1 down 3 times 2, which is 6, over 1 down 5 times 2, which is 10. See what we can fit on here. So over 1 down 2, over 1 down 1, 2, 3, 4, 5, 6. Y-intercept is negative 3, which proves out our standard form up here, which is good. And we can't fit on the down 10, so we'll just make sure we have arrows on the end here. So we've got our vertex. Now this one is opening downward because the a value is negative, so it doesn't have a minimum value, it instead has a maximum. It never gets higher than 5. Okay, so this one has not a minimum, but a maximum equal to 5. All right, next one. Okay, so again, we want to change this one into the format, vertex format. This is what we're going for. Okay, so again, the number out front, the step number is into positive 1, which is the easiest case, so we have to factor the step number, which is 2, out of the terms that contain x. So 2x squared divided by 2 is x squared. Positive 12x divided by 2 is positive 6x. And then don't factor the 2 out of the 11, so it's not inside the parentheses, and we've created an equivalent expression. So now we're ready to complete the square inside the parentheses. So x squared plus 6x, half of 6 is 3. You take half this number and square it. So half of 6 is 3, 3 squared is 9. So 9 is what completes the square, but you can't just add 9, you have to subtract 9 as well. Close your parentheses add 11. So then the first three terms inside the bracket form your perfect square trinomial. And then when you factor it, that gives you the x portion of the vertex. So it's going to factor this time to give me x, sign in the middle is positive, square root of 9 is 3, all squared. But now we have to get that negative 9 out of the parentheses by multiplying it by the number out front. So 2 times negative 9 is negative 18 plus 11. So the biggest mistake people make is they forget to multiply that negative 9 by the 2 out front. You remember maybe in grade 10 that's could have been what you had the hardest time remembering to do. So now we just have to combine the minus 18 plus 11. That's going to give me minus 7. So now I've changed it to vertex form, and we know the vertex would be negative 3 opposite sign for the x part, same sign for the y part, negative 3, negative 7. So we can plot that on our graph. And our step number is positive 2. So that's going to be over 1 up 1 times 2, which is 2, over 1 up 3 times 2, which is 6, over 1 up 5 times 2, which is 10. And 10's not going to quite fit on. So just arrows on the end. There's our graph. We've got our vertex. Now this one opens upward because the a value is positive, so it's going to have a lowest value, no maximum, but a minimum value of negative 7, which is the y coordinate of the vertex, or the k value in the equation. Okay? All right. Next question. All right, D. Y equals negative x squared plus 12x minus 31. So this one, it maybe doesn't look as hard as the last two were, but because the a value is a negative 1, not just a positive 1, we still have to do the same steps. But we would common factor out negative 1 from the terms containing x. So negative 1x squared divided by negative 1 is x squared. Positive 12x divided by negative 1 is negative 12x. That's probably one of the other common mistakes I saw in grade 10 is not taking into account what this sign should be. 12x divided by negative 1 is negative 12x. Okay, so now we're going to complete the square inside the parentheses. So to figure out the number that goes in the blank, hopefully we're getting good at that now. We take half of 12, which is 6, and square it. 6 squared is 36. But we can't just add 36, we have to subtract 36 as well. Close our parentheses, subtract 31. So that would make these first three terms inside the parentheses my perfect square trinomial. So I've got my negative out front. You can put the 1, but you don't really need to. This factors to give me x, sign from the middle, negative. Square root of 36 is 6, all squared. Don't forget the squared here because that's what makes it a parabola. And then to get the negative 36 out of the parentheses, you have to multiply by the number out front. So negative 1 times negative 36 is positive 36 minus 31. So that's going to give me plus 5. So now we've successfully put it into vertex form. So our vertex is 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And my step number is negative 1, really. So it means I'm going over 1 instead of up, I'm going down 1. Over 1, down 3. Over 1, down 5. 3, 1, 2, 3, 4, 5. No, can't quite fit 7. So there's our parabola. And this one, because the a value is negative, has a maximum or a highest value of 5. Okay, that's the highest it ever gets, which we see here and we see here. Okay. Moving up to example 4 here, determine the vertex and maximum or minimum value of each quadratic function. So we don't have a graph anymore. We're just going to put our equation into vertex form. Already, because this a value is positive, we know there's going to be a minimum value, because if we see a positive a value, we know that our parabola is going to open upwards like that. Okay, so we know it's going to have a minimum, but we don't know what that value is. It's not positive 9, because this is not in vertex form. In order to know what that number is, we have to put it in vertex form. So that's what we'll do. So we're going to factor a value out of the terms containing x. So 3x squared divided by 3 is x squared. Negative 12x divided by 3 is negative 4x. Now we're going to complete the square inside the parentheses. So to do that, we take half of 4, which is 2, and square it. So 2 squared is 4. So we add 4 to complete our square and subtract 4 so that we've really just added 0 and haven't changed the value of the equation. And these first 3 terms inside the parentheses form your perfect square trinomial, which factors to give you x minus 2 all squared. To get the negative 4 out of the parentheses, I have to multiply it by 3. 3 times negative 4 is negative 12 plus 9. And negative 12 plus 9 is negative 3. Okay. So determine the vertex. So we know the vertex is positive 2, negative 3. We knew it had a minimum because its a value is positive. Its minimum value, as we saw in all the other examples, is the k value, or the y coordinate of the vertex, either way. So the minimum is negative 3. Okay, our last example. Okay, so y equals negative 2x squared plus 16x minus 35. So just by knowing the negative 2, the a value, we know that this particular one's going to open downwards, so it's going to have a maximum value. And if we put it in vertex form, we'll be able to figure out what that maximum is. So first we want to get that a value factored out of the terms containing x. So negative 2x squared divided by negative 2 is x squared. Positive 16x divided by negative 2 is negative 8x. Now we want to complete the square. So we're going to take half of 8, which is 4, and square it. 4 squared is 16. So add 16 to complete the square, subtract 16 to keep the equation in balance, subtract 35. There's your perfect square trinomial in the box. So it's going to factor to give you x minus 4 all squared. To get the negative 16 out of the parentheses, you have to multiply by negative 2, so that's positive 32. Positive 32 minus 35 is negative 3. So the vertex is going to be 4, negative 3, and it's opening downwards. It's got a maximum value this time of negative 3. Okay. All right, and our last little wrap-up question here. How can you tell the maximum or minimum value of a parabola? So a couple things here. To tell if it's got a maximum, a is negative and the max value is k, and that's based on the equation y equals a x minus h squared plus k. And if a is positive, you have a minimum value also being k, based on the vertex form of the equation. Okay, so that's a review of grade 10, changing from standard form to vertex form. I have some questions for you to try that I will post after you feel like you understand the stuff from the video. Try the questions on paper, or if you also upload a printable copy. If you have a printer, you can print them out. Otherwise, you can just do them on paper, and I will post the solutions. So just a refresher from grade 10, get you thinking, and introducing our next unit, which is going to be on quadratic functions. Okay, stay well, everyone.